Okay, hello everybody. Good afternoon. Yeah, this is Edward Pan from Regal Technology, and I am the technical marketing manager. Yeah, in charge of the international sales department. So today I'm glad to share with you about the topics, RF component related topics, and I will introduce you some kind of the basic operation of the network analysis. So it will be focused on the principles of the component network verification. So if you have any questions during the presentation, don't hesitate to left your message on the right-hand side of the message area, and I will review it after the speech, and I will respond to you immediately. Okay. So today we will focus on the RF component applications. So as you know, the wireless communication most composed of several kind of the RF microwave component inside, just like amplifier or the attenuator or the connector or some kind of the mixer or the active or any kind of the passive device inside. So it is a very complicated scenario or diagram inside this whole system. So we will separate for each kind of the component and introduce you about how can be it workable. Yeah, based on the system baseband. Okay, so I will introduce you the scenario of the RF component. So today I will separate for 5 topics. The first one, I will introduce some kind of the RF components combined with our wireless communication among the market. And we will go through for the basic concept of the vector network analysis, basic fundamental concept in the knowledges. And you need to know some kind of the parameters of the vector network analyzer because it is very important when you implement the test and the measurement for the RF microwave component. So in the other words, you need to know some kind of the transmission line or the microwave component knowledges. Yeah, so it is easier for you to understand and go for the test and the measurement more efficiently. And for the fourth part, I will introduce you the calibration principle of the network analyzer. Because if you want to get more accurate result of the network analysis result, you need to do the calibration. Yeah, so the calibration procedure becomes a very important part of the measurement. So for the fifth part, I will introduce you some kind of the applications of the RF component and the network analysis applications. Okay. So for the first part, we will go through for the RF component. So what types of device of the RF component you need to know today? So as you can see at the left-hand side of the screen, you can see these are many kind of the RF components, including the active component or the passive component. So what is the passive component? That means it included the resistor, attenuator, cable, or connector, or some kind of the coupler or the multiplexer or the other isolator, etc. Yeah. So for the above the middle range, you can, as you know, that is a complex passive assembler. That means it will be assembled by the basic passive component, like the antennas or the switch or the mixers or the multipliers, etc. The other part is the RF active component, like the amplifier or some kind of a transceiver or the tuner. Yeah. So what is the active component? So because it is named by the active, that means it will be workable without power supply. Yeah, it will be workflow cannot without the power supply. So it needed the power to activate the functionalities in advance. Yeah, so it is called the active component. So these components are the basis of the wireless communication and the microwave system. So it is very important one. So we need to verify each by each. Yeah, depends on the performance because it is very complicated. If you don't verify each of the others, so it cannot be verified very accurate result in further. Okay. So what is the network analysis? Yeah, that means the network means the radio circuitry need the composed of the electronic components. So the analyzer, so the network analyzer is used to analyze the transmission parameters of the circuit and impedance match performance of the RF microwave device. Excuse me, if someone didn't mute your microphone, yeah, because there are many background noise, so please turn off your microphone. Okay, thank you very much. Thank you for your cooperation. So what is the network analyzer? Yeah, it is can separate for two parts. One is a scalar type and the other is the vector type. So what is the scalar type? That means you can use the network analysis tool to get just for the phase, delay, gain, voltage, standing wave, or power loss. So besides of the scalar type, we need to use the vector type to get the S parameters, even for the Smith chart, polar chart, or group delay, or any kind of the default terminal fault, testing fault, like the TDR tool. Yeah, so we can separate for two parts of the network analyzer. So it can be leveraged for the optical analysis of the energy. So you can imagine that if you instant light to a lens, go through a lens, so it will be included two parts. One is a reflected one, and the other is a transmitted one. So the light is transmitted one, that means you get the transmitted signal. And so you can get a reflective wave because this surface is not perfect. Depends on the material's characteristics. So we can get the reflected light by this one. So it can be correspond to the RF microwave device on the test. So if you send a signal from the left-hand side of the left port, you can get a reflective wave and the transmitted wave as well. Yeah, so it is the equivalent circuitry like the light wave communication go through by the optical lens. Yeah. So why do we need to test the components? The first one, it is very important to verify the specifications of the building blocks for more complex RF signal. And we need to ensure the distortionless transmission of the communication signal. It will be included two parts. One is linearities. It will be included the constant amplitude, linear phase, or the constant group delay, and also for the non-linearities like the harmonics, intermodulation, compression, analog to PM convergence. So we need to assure the battery impedance match when absorbing the power or the antenna. So that is the parameters of the network analysis. It will be included at the left upper side. You can see the linear network characterization. So it will be included the S parameters. So it is the matrix network like this one. So you can get the S11, S22 parameters for the reflection side, and S21. Oh, sorry. Sorry, I will share the screen again. Okay. So that is the network analysis, like the S parameters. And the other is the impedance match information you will base on the Smith chart. Yeah. And we need to measure the time domain characterization by the TDR functionalities. And we need to verify the vector error correction information like this one. Of course, you can use the EDA tools to do the simulation by some kind of the software tool to verify and simulate the circuitry and diagram firstly, and then go to the real test and measurement by network analysis tool. Okay. So we will go through the second part, that is the basic concept of the network analysis. I'm sorry, someone still did not turn on their microphone, so it has a lot of background noise. So please kindly turn off your microphone. Okay, it is has a better speech performance. Okay. Okay. So now we will go through for a basic concept of the network analyzer. So as you can see, we just mentioned for the previous slide, that is for the light wave transmitted to the optical lens. So we will add it to another concept, that is the impedance match concept. So it is the transmission line here, and this is a load device on the test here. So if the load impedance is matched for the transmission line impedance, that means the energy can be transmitted from the transmission line to the load perfectly and without any loss. So if the impedance not matched, that means we will have the reflected energy beside of the transmission energy. And we also have the signal included the group delay and the phase information and the phase distribution at the transmission line diagram here. So it is a basic concept of the VNA. So we need to know some kind of the definition of the parameters. Yeah, here. So you can see that is the if you divide it by the reflected wave or divided by the incident wave, that means you can get the reflection coefficient. If the transmitted wave divided by the incident wave, you can get the transmission coefficient. So the transmission coefficient, it can be correspondent to the S21 or the S12 parameters. And that represent you can get the gain or loss information accordingly. And of course, you can get the phase or group delay information as well. So as a reverse type, you can see the reflection type that you can use the reflection coefficient definitely and get the S11 or S22 parameters. And even you can get the SWR. So what is the SWR? That means you can get the standing wave ratio. Yeah, that is the standing wave. So if the impedance have the fully reflected by the load, that means you can get the full standing wave performance on the transmission line. So the basic concept of the network analyzer, so you need to fully characterize the linear network to ensure the distortion-free transmission amplitude and phase. And it can be helped to design a high efficiency matching network. Complex resistance must be measured phase. And of course, it can be reduce the system distortion and impedance mismatch errors as much as possible to achieve the high efficiency and the distortion-free power transmission. Okay, so now we'll fastly go for the parameters of a DNA. So you can see this is a matrix types of the the communication ports, that is the forward-to-port communication. So it will be included the forward reflection, reverse reflection, and the double pass the transmission direction. That means the forward transmission and the reverse transmission. Yeah, so you can get the matrix of the mathematical form of the S11, 22, 21, 12 information here. Okay. So it is the parameters of the VNA reflected parameters. You can see the reflected coefficient here. So you can get the SWR and the reflected coefficient information here. Yeah, so you can see this one. If the load is open or short status, that means you can get the coefficient by the 1, and 0 means that is the impedance matching. Yeah. So the VSWR will go for the infinite based on the reflection, and go for the 1 for the match status. Yeah. So the other is the parameters of the VNA, that is the impedance match. Yeah, so it will be included the different kind of the parameters like the impedance and admittance. As you know that the admittance is reversed by the impedance, that is related to the parallel circuitry. Yeah, so if you regard it as a parallel circuitry, that means you will have admittance to do the mathematical calculation. It is more convenient. If you want to do the impedance, that is the serialized circuitry. Yeah. So if you get the impedance match, that means the source impedance will be equals to the conjugate of the load impedance. If you want to have further more knowledge, you can refer to the textbook of the microwave engineering, on the market. Yeah. So the impedance match, you can see the basic tool, that is the Smith chart. So the Smith chart is the rectangular coordination that is twisted to here, twisted by a circular coordinate system. So it will become a Smith chart. Yeah, that means you can see the center point. That means you can have a perfect mismatch status here. Yeah, so of course you need to normalize this impedance for the 1. Yeah, and you can get the infinite load here and the 0 here. That means here is short, and the right side of the Smith chart is open status. Yeah. So the other transmission coefficient, that means you can get S21 or S12. Yeah, it is very similar to the S11, S22 calculation. Besides of that, it will has the phase information and group delay information as well. Okay. Yeah. So besides of the other parameters, group delay definition like this one, yeah, you can versus by the frequency and the wave number. So if you get the tangential curve on the diagram, that means you can get the group delay information here. And the phase delay, that means you can have the phase velocity information, and you can transfer by some kind of the frequency, angular frequency, and the wavelength. You can verify these parameters to verify the dispersion phenomena, and time required a certain frequency to pass through the reflection network. It is the TDR functionalities. It is very easy to understand. That means you can send a waveform by the original position and travel by a constant velocity, and have a reflection wave by the interrupted point. So you can times 2 pass, you can get the total distance by divided 2. Yeah, so you can get the total cable length and the default position of the cable. So it is like the time domain information, like this one. So for the methodologies of the network analysis, it will be used by the reverse Fourier transform here. Yeah. Okay. Good. So, of course, we stopped up here, and if you have any questions, we can see any kind of questions you raised up here. Let me see, okay. Okay, somebody cannot hear the voice, so let me see any kind of the problems. But I think it is no problem because my side the voice is normal. Yeah, so audio is okay here. Okay. Thank you very much. Somebody help me to verify the voice quality. Okay. Okay. So we will go for the calibration principle of the network analysis here. Okay. You can see the calibration principles. That means you can see here, because the high speed or high frequency network analysis and for the RF microwave component test, it will be generate some kind of residual parameters like the capacitance effect and the inductance effect. Yeah, so it is very important to do the calibration to remove this kind of residual phenomenon. So the most important one to remove the residual, we need to do the open short load calibration procedures. So this is the single port procedures. You can use the open short load to do the calibration. It is very easy to perform if you have the kit, yeah, like the open kit, short kit, and the 50 ohms kit, even for the 75 ohm kit or any kind of impedance values as you like. Yeah, so for the one port, that means you can just perform the single port antenna or some kind of cable performance verification. So for the reflection measurements, yeah, this is need a good termination or high accuracy with the two-port devices. And this can remove these errors like the directivity, source match, or the reflector tracking. Yeah. If you want to do the cable length S21 or S12 performance verification, you need to do, besides of the open short load, you need to do the through calibration instead of the other parameters. So enhance the response, that it will be combined the response of the one port and correct the source match of the transmission measurement. So finally, I will go through for the application sessions. Because application is very important, because the previous network analysis basic knowledge is quite boring. As I think it is quite boring because it included many kind of mathematical calculation. So I think all you guys need to know how to measure and test the network analysis. It is just okay. You don't need to focus on the mathematical calculation because it can be done by the network analyzer automatically. So the previous slide, I just mentioned you the basic knowledge, and once you know more about how can network analysis work for the test and measurement in advance, okay? So we will switch to the application sessions. Yeah. So the applications of the network analyzer, we can separate for 4 parts. So you can see the left-hand side is the network analyzer. Of course, it needs to be can analyze the component test because some kind of component like the antenna, cable, attenuator, mixer, amplifier, you can use the network analyzer to do the S11 and S21 measurement. And we can also verify the standing wave test. That means you can do the impedance match verification. And for the third part, that is system termination, matching, and debugging such as the 5G or 6G system communication matching system verification, like the impedance one or some kind of a power transfer efficiency. Yeah. The final one is the transmission fault judgment, because if you have a passive network system, you need to verify what kind of fault point where you are, where you can find it, because it is difficult to find the interrupt point or fault point even for the kilometers length of the cable or the thousands kilometers of the cable. So it is very difficult to find the fault point if there are some kind of interrupt point. Yeah, so we need to use the TDR or the DTF functionalities to verify these features. Yeah. So the component test, it will be included by the IoT, Internet of Things, or the base station like the 5G or the wireless communication system. Any kind of the auto driving system, yeah, we can need to do the transmission system or the receiver system inside the automotive technologies. Yeah. So for the industrial applications, we can separate for 3 different kinds of applications, like antenna resonant frequency. So the resonance frequency means that is an indication of antenna performance, because you can see a resonance point frequency on the diagram of the S11 parameter diagram. Yeah, so you can verify this performance by the diagram. You can see a valley curve, yeah, to verify the performance of the antenna system. Besides of the antenna, you can see the standing wave ratio. Yeah, you can see how the impedance matching status when you do the debugging of the circuitry design procedure. Yeah, and you can do some kind of the standing wave ratio of the antenna system is found to be large. The impedance parameters of the antenna system need to be matched and debugged. So here, that a Smith chart can be used to quickly determine the impedance parameters of the antenna for target rectifications and debugging. Okay, so you can see the return loss curve here. So generally speaking, if the return loss is larger than 15 or 20 dB, that means you have a good performance of the return loss. Yeah, if you for the SWR, that means if you beyond the 1.5 or the 2 SWR 2, 1.5 to 2 values, that means you have a good matching status of VSWR values. And the Smith chart, you need to do the matching status by the Smith chart when you put on some kind of component like the inductance or the capacitance. Yeah, you can see the upper semi circle of the Smith chart. That is the inductance part, and the below side is the capacitance part. That means you have the capacitance effective here. Yeah, so for the qualification of the understanding of the impedance characterization of the system, the impedance usually changes with the frequency. So, which can be intuitively understood by the Smith chart showing the impedance plan in polar coordinate. That is the whole measurement diagram like this one. So you can see the parameters here. Yeah, that is the complex conjugate information here. So you can also get the S11 curve or the SWR curve here. Yeah, so it is very important. And I will have a live demonstration to all of you guys after the presentation. Okay, so for the industrial and the applications, you can see the other kind of the fault point location of the abnormal connection components in the communication. That is especially in cable and antenna test. So it can be used to locate some kind of the fault point in communication system. Yeah. So you can refer to this diagram. You can see this peak on the diagram. Yeah. So you can see here, it is 1.05 meters. That means the cable is 1.05 meters length. Yeah, so because you can encounter the open point at the end point of the cable. So it will have a reflected wave, and you can get the peak pulse on the diagram here. So you can reverse calculate the distance by the mathematical formula. Yeah. So the other one is the active device characteristics test. Yeah. That means you can do the RF amplifier characterization, included the power gain, device linearity, or response flatness are the key items for the verification. In addition, the S11 parameters, return loss, or VSWR can be measured as well. And the passive component characteristic test, yeah, it is the same as the active device besides of the gain or the amplification parameters. Yeah, so it is very easy to understand. Okay, so it is the insertion loss. So generally speaking, the insertion loss, generally, if we less than 1 dB, that means you have a very good transmission status. Yeah, so it is very, very simple. Okay. So the other one is the phase and the group delay. And you can see the right-hand side. This is the phase shift information at the above side of the screen here. Yeah, and the below side is the group delay information here. Yeah, so it is by the vector network analyzer to see the transmission performance. Yeah. Okay, so the final one is the impedance matching. So impedance matching, that means it will be decided by how the power transmit efficiency you will be decided for. So if you have a good matching, that means you have a good power transmission efficiency. Yeah. So when the communication, the final purpose is need to transfer the maximum power to the antenna. So we need to get the maximum power to transmit the signal effectively too far away from the transmitter side to the receiver side. Yeah. So the component level impedance matching, that is by using a Smith chart with the transmission line reflected coefficient and other calculations. So the best measurement value of the impedance matching adjustment can be obtained. Like the Smith chart here. Yeah. So finally, I will introduce you the Rego's network analyzer, the functionalities. So now we will base on the basic functionalities, including the S11, S21 parameters, and DTF functionalities. So how we can implement and apply it for the device under test, like the antenna, amplifier, filter, attenuator, cable, isolator, even for the circuiter component here. Okay? Okay, so here is the presentation sessions for your reference. So now we will open for customers to raise up your questions. So any questions here? Okay, so if you don't have any questions, I will introduce some kind of the live demonstration of the instrument. Okay, so now I will share the other screenshot. Okay, here. Okay, so now you can see this is the Regal's network analyzer. The model number is the RSA 5065N. So the RSA series 5000 series, that means this is the real-time the spectrum analyzer. So our network analyzer is based on the spectrum analyzer with the tracking generator functionalities inside. Yeah, so you can see the front end side here. Here is a tracking generator of the spectrum analyzer. And the right-hand side is the receiver of the network analyzer. So this is transmitted the signal and to the devices and get the signal by the direction coupler inside to the receiver side of the spectrum analyzer. So we can do the final result calculation by the mathematical formula. Yeah, so it is very simple. So if before we do the demonstration, you can see we have different kind of the functionalities inside the real-time the spectrum analyzer. It will be included the general performance spectrum analyzer and real-time the spectrum analyzer and vector signal analysis. It will be included some kind of digital modulation test capabilities, included the modulation and demodulation. And the fourth one, we will have the EMI test capabilities. So if you have the end product need to be shipped out broadly, you need to pass the international EMI standard of the specifications. So you need to the EMI tools to do the final verification. And the vector network analysis is the fifth one. So as you can see on the left-hand side of the screen, it will be included the Smith chart here and the polar chart here and the VSWR spectrum here. And this is the S11 parameter diagram here. Yeah. So it is very simple. So we have dedicated three kind of calibration kit here. So you can do the open calibration and through calibration, short calibration, and 50 ohms calibration here. So now, after the calibration, you can hook up this kind of antenna here. This antenna I used as a 2.4 Bluetooth, 2.4 gigahertz Bluetooth antenna here. So you can see the curve S11 curve here. So it is the resonance point by the 2.4 gigahertz here. That is very accurate. So you can refer to the upper left side of the screen. You can see this one. It is the 2.37 gigahertz. So it is very accurate result. So that means we have a very good performance of the calibration by the open short load calibration here. And we also have the trajectories of the matching trajectories by the Smith chart and the polar chart trajectories. So it is very simple. So we can press the measure setup here. You can see this is a line here, can do the open short load calibration here. And if you need to do some kind of if you want to do the S21, yeah, you can see this will also have a line here to have the through calibration here. Yeah, so it is very, very simple. Yeah, so we can back to the S11 parameters here. Okay, so it is a very key point I need to mention for you. That is, if you want to measure a specific frequency range, you need to set up the start frequency point and the stop point firstly. and then go for the open short load calibration. It is very important. If you want to change the frequency range, you need to recalibrate again. So don't forget, don't misunderstand. If you want to change the frequency range, you need to recalibrate your instrument firstly, and you can get more accurate result instead of without calibration. Yeah. So it is a simple demonstration of the network analysis. So any kind of a question? Okay, I think there's any kind of there's less information. Don't worry. If you don't have any questions, don't hesitate to contact with us, even for the legal headquarters or write an email to me. I'm Edward Pan, so you can write to my email address for the first stage of the presentation slide. So welcome to contact us. So I'm in charge of the technical part. So if you have any technical issue or any kind of questions, don't hesitate to ask me, and we can have a further discussion in the future. And we wish you have a good business result and good workforce for your and product design. So we will do our best to help the customer to do the test and measurement efficiently and quickly as soon as possible. Thank you very much. Today we will end up here and see you again. Hope you can pass through the pandemic outbreak status during this month, and we can see in the future. See you. Bye bye.
You.